Hi, everyone. Today, I'm going to talk about the LCA, LCA data, and AI. I'm Nanli from Tsinghua University, and today's presentation might seem a little bit technical, but don't worry, it's actually much easier than it sounds. But I promise no one's need a PhD in computer science to understand this. Just relax. I did all the nerdy stuff already. Okay. Well, here's an overview of what I will cover today, and we will start with some backgrounds and current challenges in LCA and where there's a need for innovation. Then I will discuss some issues with LCA data. Finally, we will try to explore the pathway to a truly AI native LCA transformation. Well, around the world, there are both monetary and compulsory drivers pushing for low carbon, green, and sustainable products. But on the monetary side, we can see companies like BMW, H&M, and Apple committing to decarbonizing their supply chains. Well, on the regulatory side, policies like the EU's Fit for 50/50 package and the CBAM are setting stricter requirements. Well, I think LCA is one of the key tools for addressing the challenges of decarbonization. But although the LCA offers valuable insights, but it's not a magic bullet for the carbon footprint analysis, because the process is both expensive and time-consuming. Well, the benefits of LCA can be seen across different business areas, from the product development and the supply chain management to marketing and executive decision-making. However, implementing the LCA involves several challenges. Well, you have to do the on-site investigation, you have to do the laboratory tests, you have to do the surveys, you have the literature reviews. Well, requires significant time and resources. So such complexity highlights the need for innovation to make LCA more accessible and efficient. But now let's move to the section 2, where I will discuss some key issues with LCA data. Well, one of the biggest challenges in LCA data today is a poor data transparency and traceability. As you can see from our recent study, and even in major LCA databases, it's often very hard to find where the background data actually comes from. And even fewer processes have sources that can be fully accessible. Well, the lack of transparency makes it difficult for users to trust or verify the data they're actually working with. But besides the transparency, another big challenge is the lack of capability. I mean, the compatibility between different LCA software and data formats. As shown here, there are barriers when mapping files or importing data between tools, softwares like OpenLCA or CIMA Pro. Well, this often leads to errors and information loss during data conversion, making it harder to users for work smoothly across platforms. And finally, a major challenge, I think it will be the different databases that often use inconsistent foundational data, which leads to a lack of interoperability. Well, as shown here, even if the structure looks similar, the details doesn't always make up. So it's hard to connect or integrate data across systems, across all the different kind of softwares. But what's worse, even for the same data sets, well, the UIDs, I mean the unique ID for the same data entry can be different in different software. I mean the same database prepared for the different software, but which makes the data linking and the consistency even more difficult. Well, all the challenges are exactly why we are start looking for our own unique way to create an AI native LCA. But I think one of the major advantages of AI in LCA is its ability to handle complexity. Well, the AI can filter out this uninteresting complexity, allowing us to focus on valuable insights without getting distracted by unnecessary details. As you can see, the photo I took at the GitHub Universe conference last year. Well, the AI reduces cognitive load by providing instant feedback and simplifying workflows, empowering users to make quicker and more informed decisions. But basically, AI, I think, transformed LCA by managing the data-heavy process more effectively, while making it possible to conduct in-depth assessment without overloading the human beings like us. And let's talk about the what is AI native. But nowadays, many companies saying that they have AI native solutions. Is that truly the case? Well, I think the answer is likely no, because I think most of them just only replacing existing components with an AI-based component, or they just add a new AI-based component, or they just add a AI-based control to legacy components. Well, what is AI native? I think it's where all the components potentially use AI in and among each other. That means without AI, the system or the thing doesn't exist. I think that is what is AI native. Well, the Tiangon suite is our own solution to the AI native LCA. Well, it is composed of 4 parts. The first one is the knowledge base, then the LCA background database, and the intelligent agents, and the AI native LCA platform, I mean the software. Well, here we build the knowledge base. We have automatic declaration from unstructured data sources. Besides using the multi-model large language models like the GPT-4o, GPT 4.1, or etc., we also use the different kind of models. I mean, some of the transformer models from the Hugging Face. And these models can do the declaration thing. They can do the figure screen, they can do the parsing and analyze tables, they can transform the tables from the PDF, from the pictures, to the HTML, to the Markdown format. Then can do some paragraph merging. But besides the metadata, we also build a full text search for keywords, matching the vectors for semantic searches. We realized that a technique called the hybrid search is absolutely essential in our knowledge base. Well, the keyword search is more familiar with us. It's like what we use on Google every day. It gives back the result with exact matches, word matches. Well, the vector search is a methodology that uses mathematical vectors to represent data, allowing the search system to find them with the similar in meaning, of course, regardless of language, rather than just matching the exact words. Then the hybrid search may return a result fusion. I mean, a combination of the search result of the keyword search and the vector search. For example, the original query would be the 2020 recycled aluminum in southern Chinese cities. Well, we can do the semantic query, just use the sentence in English. Then the large language models may generate full text query in English. I mean, the list. It can generate the list of the recycled aluminum, the southern China cities, 2020, life cycle assessment, etc. I think this actually solves a big problem. Often we knew certain technical terms in one language, but not familiar with how they commonly express in others. But direct translation doesn't work well. So we often cannot find the information we are looking for. So here we use the common sense of the large language models to translate, to do the translation for us. But before the LLMs come out, well, this thing used to frustrate me every single day. So we have already established a huge knowledge base. It covers millions of the research paper, I mean, full text. We have thousands of reports and patents and the standards, books, and reports. I mean, all the knowledge are in the full text. It's about 70 billion tokens times 2, one for the full text and one for the vectors. Well, this knowledge base covers all of the LCA studies and these sources in literature. And there are more than 71 million chunks as well as vectors in our knowledge base. But this bar charts shows how different types of documents are distributed over time and going all the way back to the around the year 1900. Well, the next core component is the open LCA background database. We call it the Tiangon LCA database, but it's a collaborative effort led by our university, Tsinghua University. Well, with contributions from over more than 40 investigators, the 40 institutions and the 200 researchers. Well, we already have more than 4,000 unit processes in our database. And we think we have our users from more than 80 different countries. Well, this is TDAS. Well, TDAS is short for the Tiangon Data System. We use the TIDAS to do this word. Well, TDAS is a future-ready JSON-based LCA data system. It's a kind of the format, but that is simple to use. Well, it's fully compliant and supports eco-design, making data sharing and integration with other platforms super easy. As you can see, we have different layers here. The methodology layer, we have the LCA database development guide. Then we have the format layer. Here we have all the JSON format and JSON schema, and we have the TDAS tools. That means we can do the lossless format conversion from the TDAS to the extended LCD on the LCD conversion. Then we have the reference data packages. We have different kind of the open data and the classification mapping. Then we have the AI MCP server, both in SSE and CDIO, and we have the space API using blockchain and privacy compute. Then we have our Tiangon LCA platform. Well, we have switched from the XML to the JSON for our data. So now information moves easily from development tools to clients, servers, and databases. Well, this makes it simpler to integrate with modern frameworks like React or Vue and connects smoothly with different databases and modern APIs. And thanks to the LCD format compatible features, now we are the third biggest net database in the portal of the United Nations GLAD data network. But the first two would be the Gabi and the EcoEvent. And we are the biggest open, the first one, the biggest open and free database in GLAD. Then let's move to the part 3, the multi-level agent system. Here we have different layers of the agents. You can, as you can see, we have the basic function here. We have the agent just to do the basic things like the pattern search, the report search, the content verification, standard output, etc. And then we have the unit agents. They do the basic functions like the graph, RAG agents, the RAG, different kind of the RAG agents. Then we have the multi-agent orchestration. Here, where all the agents work together. Then we have our industrial level cloud native environment and all of the things we have deployed on the Amazon ECS. So here we show the LCA data MCP server, which is modern context protocol for managing and exchanging Tiangon LCA data. We can easily set start of the MCP server using a simple commands. Here we can do some environmental variables. Then we can open this server. We just ask AI to do the search. As you can see, they have already called the tool to search the LCA process. They can find the bauxite mining in China. Well, this thing is open source on the npm.js.org, and it can do multiple protocols like SCIO and SSE, as I just mentioned. Makes it very flexible and different in integration scenarios. Well, this thing is fully open sourced. Yeah, let's move next. Now we have seen how the MCP agent system is set up. So what it can actually do is here you can see the basic function in action. It provides globally accessible search services. Lets you can send your own requests to different knowledge databases. It instantly returns the hybrid search result for multiple sources, including our knowledge data and LCA data. Then is a cyclic graph. Well, this slide introduced, the graph-based agent system. By structuring the process as a cyclic graph, we can control and adjust each step by defining nodes and conditional edges. Well, this system combines the RAG, aka the retrieval augmented generation, with self-reflection, allowing it to retrieve, analyze, and generate answers time and time again until it reaches a satisfied response. Well, this agentic approach makes the process flexible and adaptable, while ensuring more accurate and context-aware outputs. Well, this is example of the direct clinic graph. That means every agent must follow the orchestrated workflows. It's one-way tickets. Every agent have a one-way ticket. Some agents are responsible for the restricting system boundaries. Some agents are responsible for the restricting the process time period, or some agents are just for the converting data into the TLS format. So here's an example of how the orchestration works. But basically, we'll only have three steps. The first one is the retrieving, then analyzing. The third one is the converting into the structured table. As you can see, we can extract more than 100 reliable data from 70 documents in 19 seconds. Well, because it's parallel to orchestration, we can do that in 700 or even 7,000 documents in the same time in 90 seconds. Here is how the agent works. As you can see, to start, we give some queries. Then they can get the content. You use the tools, we call the tools, to get the contents back. Then we have an evaluation agent here. We call it grade. If this agent is not satisfied, they will supplement. They will give all the other queries to redo this job, time and time again. When it's satisfied, we let to the end. Yeah, here return the flows. Well, we use that agent to do real life cycle assessment case. It's just a case of the Chinese aluminum ingot production based on the LLM agents. We have three modeling approaches. The first one would be the automatic modeling by the LCA software, like OpenLCA. The second is the human expert modeling. The third is the LLM agent modeling. Well, this is the result. But the vertical axis, different kinds of environmental impacts. Well, the pink dot stands for the human experts result. Well, the blue one is the AI agents. Then the auto link function of the software. Well, the pink plus blue is purple. As you can see, there are many purple dots and curves in the figure. But that means the AI agents can reach a level comparable to human experts. Well, on the contrary, you can see there's a significant difference in the gray ones. The gray ones is conducted by the functionality of the auto link of OpenLCA. Then the part 4, the LCA platform and the software. Here we have all the full functions of the LCA, including the data management, modeling, and calculation, and we have some verification functions. And also it's AI native, and we're still working on it. We have the intelligent data search and recommendation engine, the Copilot agentic automation is on the way. This is our URL. Well, all the things I have already mentioned above is the open sourced, and this is our technical architecture. As you can see, we have different kinds of layers of this Tiangon agentic framework. We have the LLM layer, we have the knowledge layer, the AI components layer. Here we use Python and TypeScript to do our job. And we have the orchestration layer, we have the infrastructure and the interface. As you can see, we are all open source in MIT license. Well, that means everyone can use the codes even in their commercial activities. Well, this is our open source projects on GitHub. Thanks to the AI, we have already I have already opened more than 50 new open source projects since the year 2023. And I'm also a contributor to the OpenAI ChatGPT plugin and LangChain. Well, finally, some takeaways. The first I will say is LCA is a time-consuming and labor-intensive process, often requiring practical compromises. Well, I think LCA needs high-quality, traceable data and modeling. And the AI-native LCA is a foreseeable future. And I will emphasize that the infrastructures matters. Well, the infrastructures such as human and AI accessible, both AI and human accessible LCA data structure and accurate, extensive, and detailed knowledge base and a flexible agentic framework are essential prerequisites for the realization. Well, the role of human beings like us and the human experts, I think will shift from the producers of LCA to the definers of the prompts and the selectors of the results. And that's all for today. Thank you very much.